Hey guys, it's Mr. Wolfe here, and I'm going to be going over the second part of Target 1, which is going to be on momentum. And so before I go on, one thing that I should have mentioned in the last video is what type of quantity momentum is going to be. It's going to be scalar or vector. Well, if we look at what goes into it, mass times velocity. Mass is scalar, but velocity is a vector. So it could be negative or positive, which means we could get a negative or positive momentum. So momentum is going to be a vector quantity. All right. And so we talked about momentum before, that it's just inertia in motion, the product of mass times velocity. And on its own, momentum's not too interesting. What we care about and what physicists care about is when momentum changes. So for instance, like a 1 kilogram golf ball that's just going at like 0 meters per second, being hit by a golf ball and by a golf club, and now rocketing at 75 meters per second. So we've definitely had some type of change in momentum here. Now we have to calculate how we're going to determine this change in momentum. And we're going to use this the box right here. And this is going to be an extremely important tool for this target, probably the most important part of this target. All right, so if we're going to be determining a change in momentum, how we're going to represent that mathematically is this delta, right? Anytime we have a delta, that just means change in. And so delta P means change in momentum. Another word for change in momentum. We could use these interchangeably. So instead of saying change in momentum, you could say that an object experiences an impulse. The same exact thing here. And how we're going to determine this change in momentum, this impulse, is using the equation mass times the change in velocity. Now, we could have a changing momentum if our mass changes, but most of the time our object's mass is going to stay the same. So it's usually going to be that velocity that's changing. So that's why we're using it this way here. But keep in mind, you can change momentum by changing mass as well. So let's try to find the change in momentum that this golf ball experiences. So let's just say our delta P, our change in momentum, is equal to mass times my change in velocity. So my mass in this case is easy, it's just 1. And my change in velocity, well, we could kind of just eyeball it, right? We go from 0 meters per second to 75 meters per second, and that's a positive change. So that's just my change in velocity is 75 meters per second. All right. Sometimes it's not going to be this easy, and if you're not sure how to calculate this delta V, when in doubt, let's use this equation here. So, and this is going to be for a change in any quantity. So the change in velocity is going to be equal to the final velocity. So F means final minus the initial velocity, and that naught means initial. So if we just want to do this mathematically really quick, our change in velocity is equal to my final velocity, 75 meters per second, minus the initial velocity, 0. And we're still going to get that change in velocity be 75 meters per second. Okay, so when I calculate my change in momentum, I'm going to get a positive, because it's a vector quantity, 75 kilogram meters per second. So there's going to be one more way to finding our impulse or a change in momentum for an object, besides just using our mass and our change in velocity. And anytime we're going to have a change in momentum, like for instance this golf ball right here, it definitely experienced a force, right, from an applied force from our golf club. And even though it might seem like in a split second, it goes from like 0 meters per second to 75 meters per second, if we instead of looking at a golf ball, let's look at a baseball, we could see that that force is going to be applied for some amount of time, however short. All right. So a force is going to be involved in this situation over a certain amount of time. And this is going to be time force is applied for. All right, so now we've completed the box, and this is going to be a super, super helpful tool for solving any problems with changing momentum. And since everything is going to be equal in this box, we could choose which parts of the box we want to use for a specific problem. So for instance, let's say we get a problem that asks us for a change in momentum, and they give us like things like mass and velocity. Well, we're probably going to use like these two quantities here. We'll set those equal to each other. But then let's say we have like another problem that says, all right, find the impulse, and they give you things like force and time. Well, we'll set up our problem like that. Or maybe instead it gives you variables like mass and velocity and maybe time, and says like, okay, like what's the force that was applied to that object? Well, we could set these equal to each other, all right? And maybe it's just like a simple one like up here where we find the change in momentum. So it's delta P is going to be equal to mass times the change in velocity. So we could really work with this box however we need to for whatever specific problem we're working at.